Welcome back. Let's try to get some of these other examples done. Example 2 states that if sine x equals a negative 0.37, I'd like you to find what the cosine of x minus pi over 2 is. You have to remember a few things about this. First of all, I want you to find the cosine of x minus pi over 2. Well, if you look up here, this is pi over 2 minus x, so to speak, or minus whatever theta, whatever value you have. Cosine of pi over 2 minus x is sine x. But here I have the cosine of the x minus the pi over 2. Now you have the mathematical power to change that and to reverse these, so to speak, by factoring out a negative 1. So we're going to say the cosine of negative 1 times, then I can say pi over 2 minus x. I've factored out the negative 1. Well, now look at your even identities. The cosine of a negative value is equal to the cosine of the positive value. So here if I say the cosine of negative pi over 2 minus x, well, that equals the cosine of pi over 2 minus x. So here we factored out a negative 1. This is because cosine of negative t is equal to the cosine of t, because of their even identities. Now, cosine of pi over 2 minus x is the same thing as sine x. So now we can say that's equal to sine of x by the cofunctional identities. Well, we already know what sine x is. It's right here. That's equal to negative 0.37. Boom. There's our answer. When you're doing these problems, I mean, this is not done on a calculator, but you're usually going to have an answer that is the same value or the opposite sign, S-I-G-N. You have to go through and see what the equations tell you with the identities. All right, example 3. Example 3 is the fun stuff. Now we're going to simplify the following. You have secant x minus tangent x times sine x. Now, a few things that you need to remember when you're doing this. If you see anything that is squared, ding, 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 that should tell you you're going to use one of these. If you see something that has common terms that you can factor out, for example, this said secant x. If this was also secant x, then you could factor that out. Or if this was sine x, you could factor that out. Okay, I can't do any of those. Another tool that I use sometimes is to take everything back to its roots, back to sine cosine. Similar to learning vocabulary, and you would take everything back to the root word. Here you take everything back to sine cosine. Let's try that. Secant, we know, is 1 over cosine, minus tangent is sine over cosine, times the sine that I already have. Okay, let's clean that up a little bit. I already have a common denominator. They're both cosine. So now I can just say, I can combine the two fractions and say 1 minus sine times sine is sine squared over my common denominator of cosine. Now you should be able to see something. I've got a squared value, And remember from our manipulations earlier, 1 minus sine squared, come up here, 1 minus sine squared would equal cosine squared. So if you have cosine squared over cosine, right, if you want me to write that out again, I can do that. Cosine squared is just cosine times cosine over cosine squared. They're going to reduce, and you are left with cosine x. So we have simplified this expression right here to be simply cosine x. All right, let's do example 4. It's another simplification. Example 4. It is 1 over, I think it's cosine, sorry. It's cosine x over 1 plus sine x. That whole quantity plus 1 plus sine x over cosine x. Well, you say, Ms. Reams, they're just the same, just cross multiply. Well, you can't do that because cross multiplication is only valid if you have an equal sign. That's a plus. We have a sum here. We cannot do that. All right, nothing's squared. I can't take anything back to sine, cosine because I'm already there. But I have two fractions. And when we add fractions, we need a common denominator. So my common denominator is a little messy here. Still valid, still can do it. It's just a little messier. So here with this fraction, I'm going to need the denominator of cosine x. I'm going to write that over here. Cosine x over cosine x. This side will need this fraction. So 1 plus sine x over the cosine x will need to multiply by the fraction of 1 plus sine x over 1 plus sine x. Now we have major algebra simplification here. Not a whole lot more that we're doing. So here you see you have your common denominators. So we're just going to algebraically clean up this numerator here. Cosine x times cosine x gives me cosine squared. I can combine the two fractions. I'm going to write the denominator, but I'm not going to distribute it. The whole goal, we hope, is that one of these will cancel. And if you distribute too early, then it's harder to see that you can cancel them later. So try not to distribute too early. Here, we're going to have to multiply 1 plus sine x times the quantity of 1 plus sine x. So you get to FOIL. You get to distribute. 1 times 1, 1. Inside term is sine x. Your outside term is sine x. So you have 2 sine x. And your last term is sine x times sine x, so your sine squared. Now, little trick, you look at your numerator, and there is something that you can combine in that numerator with your identities. You see it? It's one of the major identities. These two. We put sine squared with a cosine squared, and that gives us a 1. Well, we already have a 1. So now we have 2 plus still the 2 sine x over our denominator. Now what do you see? How can we simplify that numerator a little bit more? We can factor out a 2, and this is beautiful because 2 out of 2 is 1. Here I'm left with sine x, and look what happens. Look what's happening. You now have the same term. So you have 2 over cosine x, and I'm going to rewrite this as 2 over 1 times 1 over cosine x, because some people are going to need to see that. This is the same thing, but 1 over cosine x is secant x. So you have 2 times secant x as your simplified answer. Now I want you to be able to get from here to here, just to look at this, but I wanted you to see how that 2 on the numerator is the same thing as multiplying 2 times the 1 over cosine. So you just simplified this whole mess up here, these two fractions, down to 2 secant x. That's what we want. No more fractions in the answer. All right, we can't leave it this way. We have to write it as 2 secant x. Okay, one more example. If x equals 3 secant theta, use substitution to write the square root of x squared minus 9 as a function of theta. Now we went the other way in chapter 4. We had the function and we had to write it in terms of x. It was given to us in theta. Now we're going to write this function as x squared minus 9 in terms of theta. Well, I'm given x. I know what x is, so let's plug that in. Let's substitute that. I'm going to have 3 secant theta squared minus 9. Now don't be fooled right here. That is not equal to x minus 3. Remember that, okay? Some of you are going to want to take the square root of each one, and you cannot do that because of that subtraction sign. So here we evaluate, we plug in the x that we have, we square 3 secant, and that gives us 9 secant squared minus 9. Hint, hint, if these numbers aren't the same, you probably goofed somewhere, because you want to be able to factor that out. Now if you notice, I haven't taken the square root of anything yet. I factor a 9 out here. I have secant squared minus 1. Now I know the square root of 9 is 3, but I cannot pull that out yet. These are all still attached by that subtraction sign. I'm getting close because this is multiplied, but I still have to be careful, because now I can use my identities and I can say secant squared theta minus 1 is really tangent squared. So now I have the square root of 9 times tangent squared, which I can now split that up. When they're multiplied, you can split the two radicals. So that's equal to the 3 tangent theta. But I did not take the square root until the very, very end. Yes, you have a couple of these on your homework assignment. So I need you to be able to evaluate a function similar to this with x, but now substitute to get it into a function of theta. All right. This is a review of what we did in class, but I have another video of the same identity lesson using the homework assignment for 5.1 day 2 video. Thank you. I will see you in class.